Hello and welcome to G Fun Facts Online. Today we are going to talk about a phenomenon that has shaped our planet's history, erased civilizations, and inspired our deepest myths, all while leaving almost no traditional geological fingerprints. We usually worry about asteroids hitting the ground, but for centuries we have been looking in the wrong place. The true danger, and the most frequent one, doesn't strike the Earth. It strikes the sky. Let's talk about cosmic airbursts. Our story begins on a frozen morning in February 2013. It was a mundane Tuesday in the Urals. Residents of Chelyabinsk, Russia, were commuting to work under a clear, cold sky. Then, the heavens tore open. A second sun flared into existence, streaking across the firmament with a brightness that seared retinas and cast shadows that danced wildly against the snow. It was brighter than the sun, a dazzling bolide painting a thick trail of smoke across the atmosphere. Then came the silence. It was a deceptive, eerie pause that lasted for nearly 3 minutes. People rushed to their windows, pressing their faces against the glass to gawk at the lingering contrail. That curiosity was punished by a wall of invisible force. A shockwave, delayed by the distance of the explosion, slammed into the city. It didn't just rattle windows, it blew them out. Thousands of panes of glass shattered simultaneously, showering onlookers in razor-sharp confetti. Factory roofs collapsed. Garage doors buckled inward as if punched by a giant fist. Over 1,500 people were injured. But here is the critical detail. They were not injured by a falling rock. They were injured by the air itself. The object that caused this chaos never hit the ground, at least, not as a mountain-leveling asteroid. It was a rock roughly the size of a 6-story building that had detonated 18 miles above the surface with the force of 500 kilotons of TNT. That is 30 times the energy of the Hiroshima bomb. This was a cosmic airburst. To understand exactly what happened over Russia and what has happened countless times in Earth's past, we have to abandon the Hollywood image of an asteroid impact. In movies, a rock slams into the ground, creates a mushroom cloud, and leaves a massive crater. In reality, our atmosphere is a formidable shield. It acts less like a gas and more like a brick wall for objects moving at cosmic velocities. When a meteoroid enters Earth's atmosphere, it is traveling at hypersonic speeds, typically between 11 and 72 kilometers per second. That is roughly 25,000 to 160,000 miles per hour. At these speeds, the object possesses an immense amount of kinetic energy. The atmosphere cannot move out of the way fast enough. It compresses rapidly in front of the intruder, creating a shock front of superheated plasma. The pressure difference between the front of the meteoroid, which is experiencing high pressure, and the back, which is essentially in a vacuum, becomes colossal. It exceeds the structural strength of the rock itself. Most stony asteroids are actually what astronomers call rubble piles. They are loose conglomerations of rock held together by weak gravity, or they are fractured monoliths. As the atmospheric pressure mounts, the rock begins to flatten and mushroom outward. Physicists call this the pancaking effect. This deformation increases the surface area, which increases the drag, which increases the heat and pressure even further. It is a runaway feedback loop. Within a fraction of a second, the structural integrity fails completely. The rock does not just break. It vaporizes. The solid mass instantaneously converts into a cloud of expanding gas and dust. This sudden conversion of kinetic energy into heat and pressure is, by definition, an explosion. But the physics gets even stranger after the detonation. The explosion generates a spherical shockwave traveling outward. The part of the wave traveling downward hits the ground and reflects upward. This reflected wave moves faster than the original wave because it is traveling through air that has already been heated and compressed. It eventually catches up to the original wave, merging to form a vertical wall of pressure known as a Mach stem. The Mach stem acts like a giant bulldozer made of air. In a touchdown airburst, this jet of superheated gas and pressure can scour the surface, melting soil into glass and snapping trees like matchsticks, all without a physical meteorite ever touching the soil. This mechanism explains one of the greatest scientific mysteries of the 20th century, the Tunguska event. For over 100 years, Tunguska was the ultimate cold case of astronomy. On June 30th, 1908, in a remote region of Siberia, the sky split in two. A fireball descended, followed by a detonation so powerful it was detected by seismic stations as far away as England. Eyewitnesses 40 miles away were thrown from their chairs. One man reported that the shirt was almost burned off his back. It wasn't until 1927 that Leonid Kulik, a Soviet mineralogist, led an expedition to the site. He expected to find a massive crater with a large iron meteorite buried in the center. He fought through the swampy taiga, battling mosquitoes and disease, finally reaching ground zero. But what he found baffled him. There was no crater. Instead, he found a butterfly-shaped zone of devastation. Over 80 million trees across 2,150 square kilometers were flattened. They lay in a radial pattern, pointing away from a central epicenter. But at the very center, the trees were still standing. They had been stripped of their branches and bark, looking like a forest of telephone poles. This telegraph pole forest was the clue. The explosion had occurred directly above them. The shockwave had pressed straight down, stripping the branches but leaving the trunks upright, while the horizontal blast wave, further out, had knocked the trees over. Modern computer modeling has confirmed it was a stony asteroid, roughly 50 to 80 meters wide, that detonated at an altitude of 5 to 10 kilometers. The energy release is estimated at 3 to 15 megatons. If the Tunguska object had arrived a few hours later, due to Earth's rotation, it could have airburst over St. Petersburg, potentially killing hundreds of thousands of people. So if airbursts don't leave craters, how do we find them in the deep past? Geologists have had to become forensic scientists, looking for microscopic clues called impact proxies. One of the most telltale signs is melt glass. When the first atomic bomb was tested at the Trinity site in New Mexico in 1945, the heat melted the desert sand into a greenish glass called trinitite. Airbursts do the same thing. When the superheated plasma jet hits the ground, temperatures can exceed 2,000 degrees Celsius. This melts topsoil and rock instantly. When it cools, it forms impact glass, which often contains minerals that require ultra-high temperatures to form, like lechitierite or pure silica glass. We also look for microspherules. Vaporized rock and metal from the asteroid are lofted into the atmosphere. As this vapor cloud cools, it condenses into microscopic droplets that rain down over thousands of miles. These magnetic microspherules are perfectly spherical, a shape that can only form when molten material cools in free fall. Then there is shocked quartz. Quartz is one of the hardest minerals on Earth. Under a microscope, quartz grains from impact sites show shock lamellae, which are parallel lines of damage that cannot be formed by volcanoes or earthquakes. And finally, we look for nanodiamonds. In the fury of the fireball, carbon atoms can be crunched into microscopic diamonds, invisible to the naked eye but found in trillions within carbon-rich soil layers. This geological evidence brings us to the most controversial and fascinating frontier of airburst science, archaeology. Did the sky gods of ancient myth actually exist as physical phenomena? Consider the ruin of Tal el-Hammam in the Jordan Valley. In the Middle Bronze Age, around 1650 BCE, this was a thriving city-state. Then, in an instant, it ended. Excavations have revealed a destruction layer 1.5 meters thick. It is a chaotic mess of ash, charcoal, and pulverized mud brick. Archaeologists found pottery shards with their outer surfaces melted into glass. Bubbles inside the glass indicate boiling occurred, requiring temperatures of over 4,000 degrees. A paper published in Scientific Reports in 2021 proposed that a cosmic airburst, slightly larger than Tunguska, detonated over the city. The blast sheared off the top 12 meters of the palace complex and blew the city wall down. It may have also pushed a surge of supersaline water from the Dead Sea over the agricultural land, rendering the region uninhabitable for centuries. The location and timing roughly align with the biblical account of Sodom and Gomorrah. The description of fire and sulfur raining from the sky fits the profile of an airburst with uncanny precision. While this hypothesis is fiercely debated, the physical evidence of high-temperature melting remains a difficult puzzle for conventional archaeology to solve. Going back even further, we encounter the Younger Dryas impact hypothesis. Around 12,800 years ago, the Earth was warming up as it emerged from the last ice age. Then, suddenly, the planet plunged back into a deep freeze that lasted 1,200 years. In 2007, scientists proposed that a fragmented comet exploded over the North American ice sheet. The theory suggests that airbursts ignited wildfires across 10% of the planet's landmass, evidenced by a black mat of soot found in soil layers worldwide. This event is blamed for the extinction of the North American megafauna, like mammoths and saber-toothed cats, and the disappearance of the Clovis people. While opponents argue that the impact markers are not unique or are misidentified, recent findings of a large impact crater under the Hiawatha Glacier in Greenland have breathed new life into the theory. Before we had satellites and geology, we had stories. Indigenous oral traditions may contain the oldest eyewitness accounts of these events. In Central Australia, the Henbury crater field was formed about 4,700 years ago. When scientists first visited in the 1930s, Aboriginal elders refused to camp nearby. They called the place Chindu China, Waru, ch. Chinga, meaning Sunwalk Fire Devil Rock. They described a fire devil that ran down from the sun and set the land ablaze. In Estonia, the Kali crater is a rare impact site in a populated area from about 1500 BCE. The Finnish national epic, the Kalevala, tells of a spark of fire that fell from the heavens, penetrating the roof of the sky and causing the water to boil. In Argentina, at the Campo del Cielo, or Field of Heaven, indigenous tribes told Spanish conquerors that the masses of iron found there had fallen from the sky. They believed a piece of the sun had broken off. This oral history led the Spanish to the site in 1576, marking the first time Europeans discovered meteorites based on indigenous guidance. If these events have happened before, they will happen again. The Chelyabinsk event revealed a terrifying gap in our planetary defense, the solar blind spot. Most asteroids are discovered by optical telescopes that look into the night sky, detecting sunlight reflected off the rock. But objects approaching Earth from the direction of the sun are invisible to these telescopes. The glare of our star washes them out. Chelyabinsk came from the dayside sky and struck without warning. We have found over 90% of the planet killers, the ones over 1 kilometer wide, but we have found less than 1% of the city killers, objects between 30 and 140 meters wide. Many of these asteroids are as dark as charcoal, making them incredibly difficult to see against the blackness of space until they are very close. However, we are the first species in history with the ability to prevent our own extinction. The era of planetary defense has begun. In Hawaii, the Atlas and Pan-STARRS telescopes scan the sky every night. Atlas is designed specifically for the small stuff. It can give us 3 weeks warning for a 140-meter county killer and 2 days warning for a 50-meter city killer. That might not seem like much, but 48 hours is enough time to evacuate a city or instruct the population to stay away from windows, which would have prevented almost all injuries in Chelyabinsk. To fix the solar blind spot, NASA is building the NEO Surveyor, a space telescope set to launch around 2027. It will look in the infrared spectrum. Asteroids absorb sunlight and re-emit it as heat, so even a coal-black asteroid glows brightly in infrared. Sitting between the Earth and Sun, it can look sideways and spot objects coming from the daylight direction. But what do we do if we find one? We deflect it. In 2022, NASA's DART mission successfully slammed a spacecraft into the moonlet Dimorphos. It was a practice run for the kinetic impactor method. The result worked better than expected, shortening the moonlet's orbit by 32 minutes. We proved we can push a rock. ESA's Hera mission, launched in 2024, is currently en route to study the crater DART made and help refine the physics. And as a last resort, for a large object detected with very little warning, we have the nuclear option. Not to blow it up Armageddon style, but to detonate a device near the asteroid. The X-rays would vaporize the surface, creating a jet of gas that acts like a rocket engine to shove the asteroid away. The Earth travels through a cosmic shooting gallery. Every day, tons of dust burn up in our atmosphere. Every few decades, a Chelyabinsk-sized rock explodes. Every few centuries, a Tunguska levels a forest. For 4.5 billion years, survival was a lottery. Life simply had to hope it wasn't in the wrong place at the wrong time. Today, we are different. We are watching. The invisible impacts are no longer invisible to our sensors. We are finding the traces of ancient catastrophes in the dirt and scanning the skies for the next one. The silence of that Chelyabinsk morning was broken by a shockwave, but in a way, it woke us up. The next time the sky falls, we intend to be ready to catch it. Thanks for listening to G Fun Facts Online.